What if a robot could take care of its own vision just like a human being? A few years ago, that idea would have sounded like science fiction. But according to a recently revealed Tesla patent, that future may be closer than most people think. The new patent has attracted attention across the robotics industry because it focuses on one of the biggest challenges facing humanoid robots today. No matter how advanced an AI system becomes, it is only as good as the information it receives. If a robot's cameras become covered with dust, dirt, rain, oil, or other contaminants, its ability to understand the world around it can be seriously affected. Humans solve this problem naturally. We blink, and our eyes continuously clean themselves. Tesla appears to be taking inspiration from nature by developing a system that allows future robots to maintain clear vision automatically. According to the patent, the system can detect when a camera lens becomes obstructed. Once the AI notices a drop in image quality, a cleaning process begins automatically. Small amounts of cleaning fluid can be directed onto the lens surface, while a compact cleaning mechanism removes debris and restores visibility. The entire process is designed to happen without human intervention. This means a robot could continue working in difficult environments for much longer periods without requiring maintenance. For factories, warehouses, and industrial facilities, that could be a major advantage. What's especially interesting is that many experts believe this technology is intended for future versions of Tesla Optimus. A humanoid robot operating for hours in real-world conditions needs reliable vision at all times. Even a small amount of dirt on a camera can reduce accuracy and affect decision-making. If Tesla successfully integrates this technology into Optimus Gen 3, it could represent another important step toward fully autonomous humanoid robots. And based on the pace of Tesla's development, many experts believe that this self-cleaning camera system is not just a small upgrade. It may actually reveal Tesla's larger vision for the future of Optimus. For a humanoid robot, vision is one of the most important systems. Without clear visual information, even the most advanced artificial intelligence can struggle to perform basic tasks accurately. Unlike cars, humanoid robots operate in very different environments. A vehicle can sometimes rely on speed, airflow, or simple cleaning systems to keep cameras clear. A robot walking through factories, warehouses, homes, or construction sites does not have those advantages. It constantly faces dust, dirt, moisture, and other obstacles that can reduce camera performance. Even a tiny layer of contamination on a lens can affect object recognition, depth perception, and navigation accuracy. As a result, the robot may require frequent maintenance, reducing productivity and increasing operating costs. Tesla appears determined to solve this problem through automation. The new cleaning technology could allow Optimus to work for much longer periods without human assistance. Instead of stopping operations whenever cameras become dirty, the robot could identify the issue and solve it on its own within seconds. This would make the machine more reliable and practical for real-world applications. The benefits extend beyond factories. Outdoor environments present even greater challenges. Rain, mud, dust storms, and changing weather conditions can quickly affect camera systems. A robot equipped with automatic lens maintenance would be far better prepared to handle these situations while maintaining consistent performance. This could open the door to new tasks that were previously difficult for humanoid robots. Agricultural work, construction projects, emergency response missions, and outdoor inspections may become much more realistic use cases for future Optimus models. The world still doesn't fully understand what is happening inside robotics labs because humanoid robots are no longer just experimental machines moving slowly in controlled environments. They are now starting to move with more intelligence, better balance, and the ability to learn from real human behavior. And Tesla's Optimus project reached a stage where it was no longer just repeating fixed instructions but beginning to adapt, and this is where everything changed because the moment a robot can adapt, it stops being just a machine and starts becoming a system that can improve itself. Inside Tesla's testing environments, it was trained on massive human motion data, and unexpectedly it started improving its balance and coordination without direct reprogramming. In early tests it struggled with uneven weight, but later it began correcting posture in real time and distributing force across joints automatically. It was not perfect, but it was clearly learning, and this became a turning point for the entire industry as companies like Figure AI also pushed forward with the goal of building humanoids for warehouses and industrial work, machines that never get tired or lose focus. But this raised a serious question about what happens to human jobs when robots can do physical work better and more consistently. And although the change will not happen suddenly, it will slowly enter factories, logistics, and construction where repetitive work will be automated step by step until it becomes normal. But the biggest transformation is not physical, it is mental, because the next stage of humanoid robots is decision-making, where they analyze situations, choose actions, and learn from outcomes, becoming independent operational agents. And at that point the boundary between software intelligence and physical robots begins to disappear, as one AI system could exist across millions of robot bodies worldwide, all connected and learning together. The world is now entering a stage where humanoid robots are no longer limited to laboratories and demonstrations, because they are slowly moving into real environments like factories, warehouses, hospitals, and even homes. And this is where everything begins to shift, since real-world conditions are unpredictable and robots must now perform without controlled settings. Companies like Tesla are developing systems like Optimus not just to follow instructions but to understand goals, meaning humans give a task instead of step-by-step commands and the robot decides how to complete it. And as this technology spreads, humanoid robots are starting to handle continuous work in logistics, manufacturing, and dangerous environments without fatigue or risk, which looks like pure efficiency for companies but slowly changes the structure of human employment as repetitive jobs begin to shrink and automation increases. While at the same time these robots are becoming part of connected learning networks where one improvement can instantly be shared across thousands or millions of machines, creating a global intelligence system that evolves together. And this raises deeper questions about how humans will coexist with machines when they can work faster, longer, and more efficiently. And although this transition is still in its early phase, it is already clear that this is not the end of human importance but the beginning of a completely new era of work, intelligence, and human-machine coexistence. The world is now moving toward a stage where humanoid robots are no longer just part of industry, they are slowly entering everyday human life. And this is where the situation becomes even more complex, because when robots leave factories and start operating in homes, schools, hospitals, and public spaces, their role changes completely from controlled tools to active participants in society. And companies are already working on robots that can assist elderly people, help with household tasks, and even provide basic support in healthcare, which sounds helpful on the surface but also raises deeper concerns about dependence on machines, because the more humans rely on robots for daily tasks, the more those systems become part of normal life. And at the same time, military and security sectors are also exploring advanced humanoid systems for high-risk operations, surveillance, and battlefield support, which adds another layer of seriousness to this technology. And as AI becomes more integrated with physical robots, these machines are no longer just following commands but are increasingly capable of making decisions in real time based on their environment. And this leads to a future where human control may become indirect rather than direct, managed through software systems instead of hands-on actions. And while this may bring unmatched efficiency, safety, and productivity, it also forces society to think about control, responsibility, and limits, because once intelligent machines operate at scale in both civilian and critical environments, the balance between human authority and machine autonomy becomes one of the most important questions of the modern era. And ultimately, this is not just a technological evolution but a transformation of how humans will live, work, and coexist with machines in the coming years.